So you want to know how to make procedural animations? Not a problem. In this video, I will show you how I went from this to this using only one animation. Alright guys, in this video I'm going to be showing you how I set up this procedural walking system. It's going to be a really easy thing to follow. So what do you need for this system? Well, the first thing you're going to want is a idle pose. So right here we have an idle pose, but we're not going to be using any of it. We're just going to have a single frame animation. So if you have that, you're good. I set up a quick socket for the gun to be positioned properly, but once again, if you already have a system, you don't have to do this. I just did it so I can use that in my player blueprint. Okay, that's the first thing we're gonna need. Now, the second thing we're gonna need is some curve vectors. And if you have never used a curve vector before, I'll just show you guys real quick. If you right click, go to miscellaneous, and you go to curve, you can then select a curve vector. That's the one that we're going to be using. Just press select and you can name it whatever you want. So I'll just do CV test because I already made them, but just to show you guys, if you open it up, this is what it's going to look like. You have the three different lines on top of each other. Now to get them to separate, what you can do is just use your middle mouse button to create a keyframe, and you want to move them apart like so, and then you can move these ones around to create a sort of curve what you want to have, and then you can go back to the normal if you want to stop that, and then you can right click on the line, and you can say once you're done, you can right click, post infinity, and then cycle with offset. If you click on the line, and there you go. Now it will always offset the way that you have the animation set up. Okay, so that's basically the basic understanding of how to do it. Now if you want to look at the ones that I created, as you can see, they look a little bit different, but it's the same principle. So we started at 0, so 0 0, and then for my green one, which is Y, the first keyframe is at 0.5 with a value of negative 0.25. And then we go up to 1.5 seconds, which is 0.125. And then we go back to 0. Then we just go back to the normal 0, 1. For my X, it is going to be, first value is going to be 1 second and minus 0.375, and then my second one is just going back to 0 at 1.8, and then my last one, which is my Z, it will go to the first keyframe at 1.2 with negative 0.5, and then it will go back to 0 at 1.6 seconds. And then if it's looking like strong lines linearly, what you can do is you can just select the keyframe, right click, and auto it. That will make it nice and smooth for us to be using. And if you want to do walking, I have the same thing, but this is linearly. So my first keyframe on my X is going to be 0.3 seconds and minus 1.75. And then it goes back to 0 at 0.6 seconds. And for my second, which is on my Z, it will be 0.3 and minus 0.2. And then it will go back at the same keyframe. So pause the video. Make sure you guys have this. And once you do, we are going to back off because we'll be using them later. So the first thing we're going to do is open our player blueprint because we're going to need a couple of things set up before we can continue. First thing on the begin play, I created a tick timer. This is going to act as my tick basically. Now the whole reason why I am not using a tick is because it is frame rate dependent. So if you're playing on 30 FPS, it's going to look very choppy. That's why I always create my own tick event. It's on 0.001 and it's set to looping. After that, here is the tick event I was talking about. The first thing we're going to want is our player mouse inputs. So I'm going to get my mouse X and mouse Y. I'm then going to be making them into a vector 2D just so we have both variables inside of one. And then I'm just going to save that as a variable, and I called it mouse controls, but you can do whatever you want with it. And then for the second one that we're going to need is our player movement controls. I just got my IA move, so forwards, backwards, left, and right. And I set that up as another vector 2D, and I called it movement controls. But once again, you can name it whatever you want. It really doesn't matter. Now, if we look at the details panels, I have the two that I just set up. And then I also have my CV idle and CV walk in here. These are basically the curves that we've created. If you don't know how to add these, just click on a variable. I'm not going to name it. And then in here, you can go click on this and type in curve vector. And then you can select this one, which is curve vector object reference. And if you then compile on the right side, you will see that you can now select your curve. Once again, I already have this, so I'm not going to be doing it. So I'm just going to delete this and we're going to continue. All right, once we have this set up, the next thing we're going to do is we're going to go into our animation blueprint. And I already made everything, but I'm going to go through it step by step for you guys. So the first thing we're going to need is on initialize animation. So this is basically the begin play for the animation blueprint. We are going to get our owner's reference. We're going to cast to our player for that. And we're going to save that as a reference for later on. That way we can get our variables that we set up in our player blueprint. Then on update begin animation. And here's where the actual code is going to be. What I did for the first thing is as soon as we are valid on our player reference, I got my CV idle, so my curve value for idle. I then got my vector value out of that. So if you just drag out of it and type in get vector value, that will get the value of the game time in seconds. So whatever second you are in the game is going to get that value out of there. And then out of that, I just saved it as a vector variable. And I put it in a... where was it? I put it in a proc movement category. But you don't have to do that if you don't want to. I just like my code to be clean. So that's kind of what that is. Then for the second thing, once again, I did the same thing for the walk value. Basically, as soon as it was valid, got my walk out of there. Got the value that I wanted, and then I multiplied it by a walk threshold multiplier. Now what this is going to do is basically make it heavier or less heavy. Feel like the weapon will feel more or less heavy. So if I set this to 15, the animation is very heavy. As you can tell, like heavy up and down, heavy movement. If I now change this to, let's say, 5, as you can see, now the animation feels a lot lighter. So you can use that to basically increase or decrease the intensity of the animation based on what, like how heavy the weapon is. Okay, that's basically what this is. And then I just saved it as another vector variable. And once we have that, the next step I kind of did was I got my player reference once again. And I got my mouse control and my movement control out of there. And I just saved them as vector 2Ds in here. Okay. So just grab these two, save these two, and you're good to go. Now, the next thing we're going to quickly do is to make it easier. What I did is if you look at the left side, my first value, my first function rather is switch curve values. So I'm going to open that up. You make that function, you open it up. And basically what it says is I'm going to get my player reference. I'm going to get my velocity. And I'm going to get the velocity for X and Y. We don't care about Z because your movement is not dependent on if you're going up or down. So that's why I just take the X and the Y. And I check if it's equal to 0. If it's equal to 0, basically you're an idle, and we save that basically as a boolean. Is he an idle right now? And then for our curve value, here is where we're actually going to be changing between the two curves we've created. And if you're an idle, maybe it's easier if I just explain it this way. So in order to get our vector movement that we want, the first thing we're going to do is interpolate between our movement. And for our target, we kind of want to check if we're an idle. If we are an idle, then we want to use our CV idle. If we're not an idle, we basically want to smoothly lerp to our CV walk. And after that, just vinterp, it's on get world delta seconds, as it always is. And for our interp speed, I made that into a variable, so we can change this value around and make it like slower or faster, depending on the kind of game you want to have. So let's say I set this to 2, and we play. As you can see, the interpolation back to the normal one is very slow. And if I now set this to, let's say, 25, now it's pretty much going to be instant. So as you can see, it's very snappy now. It really just depends on what you want to have, but a good value that I found was 0.5. That way it still gives you a smooth kind of interpolation, but it's not too slow, so it can still fit in most games. Okay, so that's going to be our first function. If you guys need some time, just pause the video. But anyway, once we have this, the next function I want to have is actually going to be for our weapon sway. So if you look at the bottom, I made a function, called it mouse sway. So if I open that up, it looks very complicated, but it really isn't. All we did is basically I got my mouse control. I mapped it to a range, and what I basically said was my mouse X, if it is between -5 and 5, I want my outrange to be between -15 and 15, and these are in degrees, so -15 degrees and 15 degrees. Out of that, I basically did an finterp 2 out of this mouse sway rotator, which is going to be in the sway category. I just made a variable, which is a rotator. I then dragged it out here and just split the struct pin like so. And I just got the yaw and finterp that to this value based on our get world delta seconds. And for interp speed, once again, I did a sway speed variable, so you can tweak it easily without having to go into each function. And then I just set up my mouse sway rotator to this value on the yaw. And then I did the same thing for my mouse control Y. Same map range clamped, -15, 15. This one goes out of the pitch into the finterp 2. Same world delta seconds, same sway speed, and that went into my Y. Okay? So once again, it's not that difficult if you actually know what's going on. But once again, if you guys don't have it yet, pause the video and let's continue. So the next thing that we want to have is our movement sway, right? So for a movement sway, what I did was I basically duplicated the mouse sway function, and I just called it movement sway, because if we go in there, as you can see, it's pretty much the same thing. All I basically changed was I changed my movement control. So if you look at the other one, we have mouse control. Now it is movement control. That goes into the map range clamped. Same -5 to 5, but in this case for my X, I changed it to -45 and 45. That way it just has a little bit more sway to it. I like to make it exaggerated to make it easier to see. Same f-interp 2, I just made a different rotator for it. So if you look, I made a movement sway rotator. And basically you just get it out of the roll. F-interp it, same thing, and then set it to the X. And then for my Y, I did the same thing. Map range clamped, 15 minus 15. Goes into my target. And it came out of my pitch this time, and it goes into the pitch. Okay. Now, for the next one, what's our movement position sway, I once again duplicated it. I call it movement position sway. And if we open that up, this time we are using a vector. So make sure you have that correct. It's a vector because we want to move the gun forward, backwards, left, or right. And I did the same thing for the movement control. So I got the value from my X in the same thing, but this time I did -5 and 5 to make it not as intensive. And for my current, I took my mouse position sway, movement position sway vector Y. That went in there. Get world delta seconds, sway speed, same thing. Same thing over here, but this time I took my X from my vector. So that went into my current, and this was my Y. Same 5 minus 5. Keep in mind, this is reversed. So if you look on top, you have -5 and 5. In this time, you have 5 and -5, because otherwise it would be inversed. Same world delta seconds, same sway speed. And that one goes into my X, and this one went into my Y. And that's pretty much it for the functions that I have in here. Next up, we'll go to my anim graph, and this is where everything happens. So the first thing we have is my idle pose. And once again, like I said in the beginning of the video, we want to have an idle pose just on the first frame. So if you have one that has more than one frame, so just an animation, make sure you don't play it. So set the play rate to 0. After that, we just have a local to component node. If you don't know how to take this, just right click local to component. And that's gonna allow us to actually apply our modifications to it. Now the first thing we have is copy bone. Now if you guys don't know what copy bone does, basically if you look at the details panel right here, you have a source bone and you have a target bone. Now, for my source bone, I have hand left, and my target bone is going to be IK hand left. Basically, what we're going to do is when we apply procedural animations on top of our character, we're going to be doing it on the IK hand gun bone. So if I look at here, we have an IK hand gun, and we have IK hand left and right connected to it. So we don't want to move our hand left itself, but we want to move the IK behind it. So all the copy bone really does is just copy the IK's movement and apply it to our normal mesh, to our hand left. So we just copy those, so hand left, IK hand left. And the same thing over here. I have hand right and IK hand right. And then for the values, I just said copy translation and rotation. You don't need to copy the scale because it's usually always 1:1. Once we have that, we have our first transform modify bone. If you don't know how to find this, just right click, if I can, transform modify bone. And what we're going to be setting up is on our IK hand gun, which is the actual socket that we're going to be using. I just set my movement, so our translation, to add to existing. And what it's going to do is everything that happens before it, we want to apply on top of it. So you do add to existing. And for our value, I just took my V movement vector, which, if you forgot, is the actual vector that we have right here in our interp node. So we're going to be using that for this one. And what it basically does is I can show them one by one, I suppose. Might be a little bit easier if I just do it this way. So let's say we only take this one, right? If I now play the game, I do need these ones in here. I'll explain later why that is, but we do need these two in here. So I'm just gonna connect that up. There you go. So what it does is it basically just switches between the two different poses. So the curve vector for idle is playing right now. And if we start moving, it plays the walking curve that we made. So that is that. And we're going to continue. So the next thing we want to add is our mouse sway animation. And this one is for the function that we have created right here. So for our mouse sway. So we're going to add this in here. Once again, it's another transform modify bone. So you can just copy and paste them over. And for this one, I set my translation to ignore because we're going to be using our rotation this time. So for my rotation, I have it set to add to existing. And my variable is my mouse sway rotator that we made. And what that is going to do is if we press play, if we now look around, we have our procedural looking around set up. So I can move to the right, my gun moves slightly to the right, to the left. Doesn't matter. And it's nicely interpolated between every frame. Nice. Now that we have that, we can take it one step further. If we now take our next one, which is our movement sway, we add that in here, like so. Our movement sway is basically our second function that we made, our third one, which is the movement sway. Out of that, I did the same thing, so you can just copy these. And this is my movement sway rotator this time. What that is going to do is if we move forward without touching the mouse, the gun will tilt slightly downwards. If we do backwards, it goes up slightly. If we go left, it tilts to the left, and right to the right. Basically giving another layer of animation on top of it. And if we combine that with our mouse, we get some pretty smooth movement already. But we can still take this one step further by adding my movement location sway animation. That's a long thing. Okay. Anyway, it's the same transform modify bone. Basically for our rotation, we've ignored it this time and we added our translation mode add to existing. Our variable is our movement position sway vector. So the one we have right here. And what this one is going to do is it's going to add some movement to the weapon if we move around. So if I press W, the gun goes backwards a little bit. If I press S, the gun goes a little bit backwards. This one is backwards. This one is forwards, to kind of show that we're moving backwards. And the same on the left and on the right. It's very subtle, but it does make it look a lot better. The last thing we're gonna need for the animation graph is our 2-bone IK. And what our 2-bone IK is going to do is basically connect our hand to the IK so that every movement we do, our entire limb, so from our upper arm to our lower arm, is going to be connected up. So what I did is for my left hand, I set my IK bone to be hand left. And then for effector, I set it to bone space. Take rotation from effector space to true. And then the effector target is going to be our IK hand left. And if you connect that up, what you're going to see is you're going to have a little gizmo at the bottom. That way you can move your elbow a little bit up and down to make it look a little bit better. And then I just copy and pasted it. For the IK bone, hand right. Effector is still the same. And then for my effector target, I did IK hand right. And you get the same gizmo, move your elbow till it looks a little bit better. And then if we go into our event graph, because for you, nothing is going to work right now. And it makes sense. Because what we have to do is after setting our movement controls, what we want to do is basically apply the procedural animations to it, right? So what I did is just add each function that you have. We add them right here at the back. And this is basically going to tick on each frame now and give you the animation that you want. So After everything is done, it should look something like this. And, well, same thing right here. Now, if you're not following along with the tutorial, that's completely fine. This isn't really a step-by-step, like I said. So what I did is, in the description below, there's going to be a link to a Google Drive where you can just download this project for free. If you want to take some more time to look at how everything works and how everything looks, it will be free to download. All I can really ask you is, if you enjoyed this and you find this helpful, leave a like on the video, maybe comment that you learned something, tell me what you guys want to see next, and if you can, please subscribe. I'm trying to hit 1,000 subscribers by the end of the year, so your help is really appreciated. But yeah, at the end, this is our final result that we have, which is a pretty smooth animation that basically came out of having one animation setup. But yeah, that's about the end of the video. I hope you guys enjoyed it once again, and I'll see you guys in the next one. Bye bye now.